Hey guys, so we are going to talk about how to multiply and divide rationals. So to do that, let's just do a quick review on just multiplying and dividing fractions, just with easy numbers. You know that when we're multiplying fractions, you can just multiply straight across, top times top, bottom times bottom. But sometimes you would want to simplify those fractions before you do that so you get nice smaller numbers easier to work with. So for example, in number 1 part A, or this review part A, instead of doing 22 times 81 and getting some huge number and then 27 times 44 to get some other big number and then having to simplify that fraction, we can simplify diagonally. You can simplify either vertically, like 22 over 27 doesn't simplify, but I know diagonally 22 divided by 44 can simplify to just 1 over 2 times. That 81 over 44 doesn't simplify, but 81 divided by 27 is just 3, which I can write as 3 over 1. And so now I can just multiply straight across. I know that 1 times 3 is 3. I know that 2 times 1 is 2. This fraction cannot be simplified, so that's our answer. Going to part B, when dividing by fractions, you know that you can always multiply by the reciprocal. So I'm going to go ahead and rewrite this problem. So instead of 7/6 divided by 1/12, I can do 7/6 multiplying by 12 over 1. Again, I know that I can multiply straight across and get 7 times 12 is 84, divided by 6 times 1 is 6, but 84 divided by 6 does reduce. Instead of working with those bigger numbers, I can simplify my fractions before multiplying. I can't simplify 7 over 6, I can't simplify 12 over 1, but I can simplify diagonally. I know that 7 divided by 1 is just 7, and I know that 12 divided by 6 is 2. And now I just have 7 times 2, which is 14. Much easier to work with, okay? So the same concept is going to be used for rationals. So here we have to simplify these fractions. Going back to just numbers, let's look at something in this little box here. It says when you cancel out terms in a fraction, you have to factor first, okay? And let's see why. Look at the example with numbers. If I did 2 over 4 plus 1, if I had to simplify that first, or let me rephrase that. If I was just doing this problem, I know that 2 over 4 plus 1 is really just 2 over 5, right? And I can't simplify that. That would be my final answer. If I tried to simplify first, doing 2 divided by 4 and then plus that 1, I would be getting something like 1 over 2 plus 1, which is 1 over 3, which is not equal to 2/5, which we know is the correct answer. Okay, same thing for the 6 plus 1 over 3. Well, we know 6 plus 1 over 3 is 7 over 3, right? And we cannot simplify that. That would be our answer. If I tried to simplify before, doing 6 divided by 3 is 2, and then 2 plus 1 is 3, 3 does not equal 7 over 3. Okay, so you can't just start canceling out things before factoring. Okay, so let me go ahead and erase this. So let's go ahead and look at example 1 part A, simplifying. So like I said, we have to factor first. Just like graphing rational fractions, we had to factor first before looking for all those characteristics. Well, I cannot simplify, or I cannot factor, my numerator. I can factor my denominator. There's a GCF of x squared, leaving me with x minus 1. Okay, now I can simplify. We know that when we divide things with the same base, we subtract our exponents. So I know I have an x cubed up top and an x squared in the denominator. So because they have the same base, I can just simplify by subtracting those exponents. And when I do that, I get x, right? X to the first power. So that's staying in my numerator, x, still over x minus 1. I cannot simplify that any further. I cannot cancel anything out. So that is my final answer. That is number 1 part A. Okay. Number 1 part B. Again, first things first, we have to factor. cannot factor my numerator, so I just have 2x. In my denominator, I can factor that out. Again, there is a GCF of x squared. So when I take out that x squared, I'm left with 4x minus 1. Okay, and then I go through and I try to simplify as much as I can. I see that I have an x term on top and an x term on the bottom. In the top, it's x to the first power. In the bottom, it's x to the second power. So when I subtract those exponents, I do get x to the negative 1 power. You know that when there's a negative power, it goes into the denominator, or it changes location. If it's in the numerator, we bring it to the denominator. If it's in the denominator, we bring it to the numerator. So now we're left with 2 over x times 4x minus 1. Is there anything else we can cancel or simplify? No. So that is our final answer. And then one more time with part C. So in part C, we have 2x squared plus 4 over 6x squared. Again, we have to factor first. Okay, let's try to figure this out here. Okay, so factoring our numerator, we get 2 times x squared plus 2, GCF, over, cannot factor anything in the denominator, so that's just a 6x squared. Now I look for anything that it can cancel out or simplify, and that is going to be that 2 out front and that 6 in the denominator. So this simplifies into just x squared plus 2 over 3x squared. That x squared in your numerator and that x squared in your denominator cannot cancel out. Okay. There we go. Okay. So now that we know how to simplify our fractions, let's get into actually multiplying those fractions. We're trying to find the product. Notice it also says we need to list the excluded values. Remember when we talked about rational fractions, we're talking about some polynomial divided by another polynomial. Our denominator can never equal 0, because if there's a 0 in the denominator, that value is undefined. So excluded values are going to be those domain restrictions. Where do we look? In the denominator. Think of those vertical asymptotes. Remember, our denominator can't equal 0. So we know that to multiply fractions, we can multiply straight across. But before we do that, we can also simplify as much as we can. So you can simplify either with your numerator and your denominator, but you can also simplify on that diagonal as well. Don't forget about that. So when I see this first example, problem A, 6x squared y divided by 3xy cubed times 9x to the 5th y squared divided by 2y. I want to simplify this as much as I can. So what I see is I see that I can simplify my 6 over 3 to a 2. I see that an x squared divided by x would just give me an x. And then I see a y divided by y cubed would technically be giving me a y to the negative 2 power. Because I know it's negative, I know it's going to go in my denominator, so that'll be a y squared in my denominator times. Let me go ahead and simplify as much as I can in the second part. 9 divided by 2 cannot be simplified, so I'll leave it as a 9 over 2. I only have an x term in the top, so that has to stay, obviously, x to the 5th power. And then I have a y squared divided by y. Well, 2 minus 1 is just 1, so that means I just have a y in my numerator. And now I can multiply my fractions. So multiplying straight across, I know that a 2 times a 9 is an 18. I know that x times x to the 5th is x to the 6th power. And then there's nothing to be multiplied with that y, so it stays over 2y squared. And then again, I can simplify some more. I know that 18 divided by 2 is just 9. There's no x's in my numerator, so I still have that x to the 6th. And then I have a y divided by a y squared. So 1 minus 2 is a negative 1. Because it's a negative 1 on that y, that means it's going to stay in my denominator. And there we have it, our final answer. Notice also going back up to this part right here, I could have simplified again with that 2x on the top left and that 2 on the bottom right, those 2's could have canceled out, and then I would have just been left with that x times 9x to the 5th y, which is going to give me that 9x to the 6th y, over just a y squared, and then I can simplify those y's. I could have also looked at this point and said, oh, a y in the top right and a y squared in the bottom left could cancel out as well. So it's kind of whatever you see, whatever you feel comfortable with, but just try to simplify as much as you can before actually multiplying straight across. Okay, and so now let's work on part B. So remember, we want to factor first. I didn't say that in part A because I knew that we couldn't factor it, but you always want to think factor first and then simplify. So when I look at part B, I know I can definitely simplify those fractions, or excuse me, I can definitely factor the parts of those fractions before I simplify. So factoring the first fraction, I know I have a GCF of 5x. So I pull that out, I have 5x, and then that would be a 1 minus x over x squared minus 4x plus 3 is factorable. There are factors of 3 that add up to negative 4, and that's negative 1 and negative 3. So I have x minus 3, and I have x minus 1. So I've factored the first fraction. And then let me go ahead and make this a little bit smaller. And then I have my second fraction that I can also factor. So my numerator, I have that x squared minus 5x minus 6. And I know that I can factor that. Factors of 6 that add up to negative 5 would be negative 2 and negative 3. So I have an x minus 2 and an x minus 3 over just that 5x. Okay, and so now that it's factored, I'm going to look for ways of simplifying before I start multiplying across. Well, the easiest thing that I see is here and here. Done. 5x divided by 5x is just 1, so that cancels out. I also see that I have this x minus 3 and this x minus 3, so that will cancel out as well. Okay, is 1 minus x the same thing as x minus 1? No, it is not. However, if we want to make it so that they are the same thing, we could rearrange that 1 minus x into negative x plus 1. It's still not the same thing as x minus 1, but then what I could do is I could take out that negative. So what do I mean by that? Well, if I rewrite this as a negative x plus 1, I'm going to go ahead and just multiply straight across, times x minus 2 over, all that's left in the denominator is just an x minus 1. That negative x plus 1 and that x minus 1 are looking very, very close to being the same thing, so I can cancel each other out. All I need to do is factor out that negative, which would leave me with negative x minus 1 times x minus 2 over x minus 1. And now I can cancel out these two things, so I'm just left with a negative x minus 2. You can obviously leave your answer like that, or you can go ahead and distribute in that negative and have it as negative x plus 2. Either one is totally fine. Okay guys, sorry about that. So I totally forgot to list our excluded values. I know that if we were in class right now, you would probably said something, right? Right. Okay, so going back up to number A, remember we could not factor that in the beginning. There's no way to factor either side of that problem in part A. So we can go ahead and list our excluded values right from that point. I have a 3xy cubed in one denominator and a 2y in the other denominator. So because my denominators cannot equal 0, that means that x cannot equal 0 and y cannot equal 0. I always want to list my excluded values from the original factored problem. Okay, even if you cross something out, it is still excluded at that point. So even though our final answer doesn't have an x in the denominator, x still cannot equal 0 because of the original problem. Okay, and then going to example B, once we had it factored out, notice what was in our denominator. We had an x minus 3, we had an x minus 1, and we had a 5x. That tells me that our excluded values for part B would be x cannot be 3, x cannot be 1, and x cannot be 0. Because if x minus 3 is in our denominator, what value of x makes that 0? 3 does. The 0 of that factor is 3, so x cannot be 3. X minus 1 is the factor. What's the 0 of that factor? 1, so x cannot be 1. For 5x, 5 is just a constant. X is what we're really worried about. What is the 0 of that factor? 0. So x cannot be 3, 1, or 0 for part B. Okay, and now we have example 3. It says find the quotient and list the excluded values. So instead of dividing these fractions, we know we can multiply by the reciprocal. Listing those excluded values is something we want to look at right after we factor these problems. So what I'm going to do is I'm going to factor and multiply by the reciprocal in the same step. So I cannot factor 7x cubed, so it stays as 7x cubed divided by. I can factor 2x minus 10 into 2 times x minus 5. Multiplying by my reciprocal, that means that x squared minus 11x plus 30 is going to go at the top. So factoring that, I need factors of 30 that add up to negative 11. That's going to be that negative 6 and negative 5. So I have x minus 6 and x minus 5 over the x squared minus 6x has a GCF of x, so that leaves me with x times x minus 6. So now that everything is factored and I've multiplied by the reciprocal instead of dividing, I can look at my excluded values. So I know that for this one, my excluded values would be x cannot be 5, x cannot be 0, x cannot be 6. So there's one part of my answer. Now at this point, I want to go ahead and simplify and cancel anything out. Boom, 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 boom. Okay, looking at what's left, I see that 7 divided by 2. That doesn't simplify, so it's still 7 over 2. I see an x cubed divided by an x. I know that simplifies to just x squared. There you go. Final answer. Part B. I'm going to do that in a blue color. All right, so part B, again, we need to multiply by a reciprocal and we need a factor. So factoring the left-hand side, factoring is going to give you, I'll come over here, 2x minus 3 times 3x plus 5 over 4x squared times 1 over x times 3x plus 5. Excluded values, x cannot be 0, x cannot be negative 5/3. Start canceling out anything that can cancel here and here. So that leaves me left with 2x minus 3 over 4x cubed. Okay, and then our last problem, problem C. I'll change my color again, and I'll come down here. Sorry, I'm all over the place. I'm going to go ahead and rewrite this. X plus 1 over x squared, already factored for us. Instead of dividing, I'm going to go ahead and multiply by my reciprocal, which is going to be x over x minus 2. Everything is already factored, so I look for things that can cancel out. Oh, before that, excuse me, I'll look for my excluded values, which is going to be x cannot equal 0 and x cannot equal 2. Looking at those denominators. Now I'm going to look for things that cancel out. Well, x plus 1 and x minus 2 don't cancel out, but I do see an x divided by an x squared, so I know that those can really just cancel out to an x to the negative 1 power. X to the negative 1 power is going to stay in that numerator. So this is going to leave us with x plus 1 over x times x minus 2. If you would like to expand that denominator, you totally can, but it's not really going to benefit you in any kind of way. If anything, I'd like to see it just stay in factored form. Don't take the extra step unless you really, really need to. And there you go.